Now we're going to work out these two problems. So these are trig integrals. So the reason they're trig integrals because we have these particular expressions right here, as you can see in the problems. So let's go ahead and recall what are the substitution we're going to be making. So remember that if you have, let's say, some a squared minus x squared, then you're going to use the substitution x equals a sine theta. And you carry on from that. Second form, if you have, let's say, x squared minus a squared. In that case, we're going to be substituting x equals a secant theta. And lastly, if you have the form in your integrand, either x squared plus a squared or a squared plus x squared. If you have any of these form, then you're going to make the following substitution: x equals a tangent theta. So remembering these three will help us a lot to work out these problems. So let's take a look at the first problem. So we have 1 plus x squared under the square root divided by x. So now this looks like this form right here, or the second one really. It doesn't matter. So you could think of it, we have this form. So we're going to use the substitution x equals a tangent theta, where a is 1, because you can rewrite 1 as 1 squared. So let's take a look at that. Okay, so we're going to let x equals 1 tangent theta. Then dx, it's going to be secant squared theta, d theta. And now we're going to go ahead and replace this into our integrand so that this will become the following. So you'll have the square root of 1 plus x squared. So this is 1 plus tangent squared theta divided by x. Well, we said x is, again, tangent theta. So I'm going to go ahead and write tangent theta right here. And dx is replaced with secant squared theta, d theta. All right, so now once we have done that, let's simplify this. And you should remember the identity that relates tangent and secant. So we know that tangent squared theta plus 1 is equal to secant squared theta. So this will be the useful identity for this problem. So I'm going to go ahead and replace that right here. So this will become secant squared theta. So we have the following form now. We have the integral of the square root of secant squared theta over tangent theta times secant squared theta d theta. Now here you can simplify these two pieces a little bit more. Square root of secant squared theta, assuming it's in the restricted domain, this will simply be secant theta. So you have secant theta once you simplify it, and we have secant squared theta from before divided by tangent theta d theta. This little bit more. So we have the integral. Now, this I can rewrite tangent theta. Tangent theta can be written as sine over cosine. So you have secant theta times secant squared theta over sine theta over cosine theta d theta. And just a lot of rewriting before we can even integrate this. So this will simplify further. So we have, I can also rewrite this piece as 1 over cosine. So check this out. So I have 1 over cosine theta. I'm still keeping secant squared as it is. And then I have 1 over sine over cosine, which is really cosine theta over sine theta, d theta. So I just reciprocated this. Now I can simplify. So as you can see that these two will cancel each other. So what we're left with is the following. So we have the integral of secant squared theta times, now I have 1 over sine, that's right here. So sine is in the denominator. You can write that as cosecant theta d theta. Now once you get to this step, we're going to use this identity again right here. Tangent squared theta plus 1 is secant squared theta. Now I'm going to go ahead and replace this with the identity, tangent squared theta plus 1. So we have the integral of tangent squared theta plus 1 times cosecant theta d theta. And just keep going. Now here I will distribute this. So we have the integral of tangent squared theta times cosecant theta plus, and I'll separate it into two integrals, plus the integral of cosecant theta d theta. Now this, we know this is from our previous calculus course. This is negative ln of cosecant theta plus cotangent theta. And then now this integral, we will have to just work it out. This can be done in the following way. So I'm going to go ahead and rewrite tangent squared as sine over cosine squared. So this would be sine squared theta over cosine squared theta. And cosecant, I'm also going to rewrite that. This is 1 over sine theta d theta. And now the reason I rewrote, because I can cancel one factor of sine with 1 over sine. So then this becomes the following. We have the integral of sine theta over cosine squared theta d theta minus this piece which we successfully completed, ln of cosecant theta plus cotangent theta. And now we can do a u substitution for this integral. Let u to be just cosine theta, then du would be negative sine theta d theta. And now if we finish up integrating, this would give us the following. This would be the integral of negative 1 over u squared du. And of course, I'm going to carry out the answer as I am going along. So the integral of 1 over u squared du, that's going to be negative 1 over u. Plus c, of course, and I'm carrying that answer with me, minus ln of cosecant theta plus cotangent theta. And finally, we plug in what u is, so this double negative will disappear. So u is cosine, so we have 1 over cosine theta minus ln of cosecant theta plus cotangent theta in absolute value plus c. Now we need to go back to our original variable. So we finished integrating in the theta variable. Now let's go back to our variable x. So that we're going to recreate from this substitution. X equals tangent theta. So to go back to the x variable, we're going to use this from before and create a right triangle. So here's our right triangle. And let's suppose theta is right here. So let's suppose tangent theta is x over 1. And we know tangent is defined as opposite over adjacent. So this is opposite over adjacent. So x is the opposite length, 1 is the adjacent. So that means the hypotenuse is square root of x squared plus 1 squared. And now we can retrieve our trig functions from here. 1 over cosine, that's really secant. So cosine is defined as adjacent over hypotenuse. So this would be hypotenuse over adjacent. So we will have this written as the square root of x squared plus 1 minus ln of cosecant. So cosecant is the reciprocal of sine. So sine is opposite over hypotenuse. So cosecant will be hypotenuse. So that's square root of x squared plus 1 over opposite plus, and then cotangent is adjacent over opposite. So this is 1 over x in absolute value plus c. So there you have it. This is our final answer for this problem. Now for this problem, before we can make our substitution, we have to play around with this piece a little bit more so that we can identify which of the 3 forms it has. We're going to complete the square. So we have x squared plus 2x. To complete the square, you need to add an extra factor, which would be b over 2 squared term. So in this case, this coefficient is your b. So we're going to do 2 over 2 divided by squared. So that's going to be 1 squared. That's 1. So I'm going to add 1. Now, of course, I can't just add an extra term. I'll have to take away that same term. Now, once I have done that, I can rewrite. This can be factored into x plus 1 whole squared, and we still have a negative 1. So that's what I'm going to replace right in here. So our integrand is now the square root of x plus 1 squared minus 1 dx. So what we did, we just rewrote the inside of the square root so that we can identify which form. So now think of this is your x squared and this is minus 1 squared. Now it has the form that if you have some x squared minus a squared, we make the substitution x equals to a secant theta. So that's the form we have, except we don't have just x squared, we have x plus 1 being squared. So we're going to make the following substitution. We're going to let this be treated as x. So we will let x plus 1 be equals to a is 1 equals secant theta. So that means if I take the derivative on both sides, derivative of x, that's just 1. So we have dx, derivative of 1 would be 0. Derivative of secant, that's secant theta times tangent theta, d theta. All right, so this is what we're going to replace back into our integrand. So we have the integral of the square root of x plus 1 squared. Well, x plus 1 is secant, so this would be secant squared theta minus 1 times dx. Dx is secant theta times tangent theta, d theta. And now we just simplify. So here we're going to be using that same identity from before, that tangent squared theta plus 1 is secant squared theta. So we don't exactly have that. We have secant squared minus 1. So if you subtract 1, you get tangent squared theta is equal to secant squared theta minus 1. That's what we're going to replace right here. So secant squared theta minus 1 is tangent squared theta. So we have the integral of the square root of tangent squared theta. And this is still secant theta times tangent theta d theta. Now we just simplify. So assuming it's within its restricted domain, I can simplify this piece. This is going to be the integral of just tangent theta times secant theta times tangent theta d theta. And now we're going to be simplifying this further. So I will combine these two together. Hopefully that will simplify. So we have the integral of tangent squared theta times secant theta d theta. Now here I'm going to use this identity again. So I know tangent squared can be replaced with that. So we're going to replace that identity right here, tangent square. So we have the integral of secant squared theta minus 1 times secant theta d theta. And now we just keep going. So here we're going to distribute and hoping it will be a successful integral. So we have the integral of secant cubed theta. Let's break it up into two pieces, times d theta minus the integral of secant theta d theta. So now this piece is easy to integrate, but this one we need to do integration by parts. So this will be done by integration by parts. But the second integral, that's from memory, we know that integral is simply ln of absolute value of secant theta plus tangent theta. And we'll write down plus c once we finish. So let's go ahead and finish up the first integral, secant cubed theta by parts. So we're going to choose u, and we're going to choose dv from the integrand. So, but the way you're going to do this, you're going to break it up in the following way. So let me hold on to this a little bit further. So secant cube theta, you can write it as the integral secant squared theta times secant theta d theta. So I just break it up this way. So then I'm going to pick dv to be secant squared theta d theta and u to be secant theta d theta. And I fill in the missing variable. This will be the derivative of u. This will be the integral of dv. So derivative of secant, that will be secant, so mistake, just secant theta will be u. This would be secant theta times tangent theta d theta. And then v would be the integral of secant squared, which is simply tangent theta. And now we're ready to integrate. So the integral of secant cubed theta, d theta, happens to be u times v, that's secant theta times tangent theta minus the integral of v du. So that's going to be secant theta times tangent. So that'll be tangent squared theta d theta. All right, so now here we are almost ready to finish up the integral. So here's what I'm going to do the following. I'm going to rewrite this as the identity, tangent square. So that happens to be secant square minus 1. So we have negative the integral of secant theta times, this is secant squared theta minus 1 d theta. Here I distribute. So you'll see the following will appear. So let me rewrite the rest of the pieces. So these are just carrying along. So now if I distribute this, I have the negative integral of secant cubed theta d theta, and then minus 1, so the plus the integral of secant theta d theta. And this is equal to all of this. So I'm again going to be copying and pasting my previous terms. All right, now you see that this integral we know how to do. That is ln of secant plus tangent. So that we can take care of. But you see here, the integral that we're solving for happens to repeat itself. So we're going to treat it as a variable and add it to the other side. So I'm going to add the integral of secant cubed theta d theta to both sides. So this is what we're going to get. And now once you do that, you'll have two of the same integral. 2 times the integral of secant cubed theta d theta is equal to the rest of it, tangent theta secant theta, plus that integral which I mentioned, this is ln of secant theta plus tangent theta. And then of course plus c, where we could write it or just hold on to it. And now to solve for this integral, all we need to do is divide it by 2. So we're going to do that. So our integral secant cubed theta d theta is 1/2 of all of that. So 1/2 secant theta times tangent theta plus 1/2 ln of secant theta plus tangent theta. All right, so this is our answer for that integral. Now let's put all the pieces together. So right, so this is the problem we initially started. So secant cubed theta minus secant theta. So for secant theta, we got this piece right here. And then for secant cubed theta, we just got this pieces right here. So our final answer would be, well, almost the final answer is this minus this. So this is equal to that. And we can combine some like terms. For example, these two can be put together. So we can say our final answer is 1/2 secant theta tangent theta plus 1/2 minus 1. That would be a negative 1/2 ln of secant theta plus tangent theta plus c. All right, so let's go back to our given variable x. So we know we made the following substitution. X plus 1 was secant theta. So from this, we're going to be creating our right triangle. So here's our right triangle. And let's suppose this is theta. So we know secant is 1 over cosine theta. So if that's theta, then this is the opposite length. Here's the adjacent. This is the hypotenuse. So cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. So this is the length x plus 1. Adjacent is right here. So that means the opposite length would be x plus 1 squared minus 1. Okay, so now if we retrieve our trig functions from this triangle, we have 1/2 secant theta, which is simply x plus 1. Tangent theta is opposite over adjacent, so this would be the square root of x plus 1 squared minus 1, because our adjacent is over 1, plus, or minus rather, minus 1/2 ln of secant, that's again x plus 1, plus tangent, that's square root of x plus 1 squared minus 1, plus c. So there you have it. This is our final answer for this problem.